Lesson 6.6 is on describing dilations. So dilation, maybe you've gone to eye doctor before and you get your eyes dilated, okay? So what that's doing is, you know, the one part of your eye, they're making it bigger so they can see things better on your eye, which then, you know, it really opens that part of your eye that lets the light in, and then everything's just super bright, and it's hard to read things and hard to see for a little bit until they get back to normal. So dilation in that case is enlarging that part of your eye. Dilation could be enlarging or reducing or shrinking a figure, creating a similar figure. If you've ever done something on like Microsoft Word or a program like that, you know, you've worked with something before where you can make like this, right? If you drag on the corner, makes it bigger or smaller. Okay, if you just drag from one side or the other side, it just stretches it one direction. But from the corner, you're creating a similar figure. And that's the idea with the dilation. We're creating a similar figure. It's not the exact same, but the sides are proportional to each other. Okay? So the scale factor is the number you multiply the original side length or coordinates by to get the new side lengths or coordinates. We'll talk about the coordinates part in a minute. If we think about the side lengths, here's an example. Is if we look at these two rectangles, you can see the one has dimensions 2 inches by 3 inches. The other one is 10 inches by 15 inches. Well, how did we get from 2 to 10? How did we get from 3 to 15? We multiplied by 5. Okay, the number you multiply by is called the scale factor. Okay, and you might say, well, what happens if it gets smaller instead of bigger? So in other words, if this was flip-flopped and I was starting with the 10 and 15 and I was going to the 2 and the 3, and you might look and say, oh, well, I'm dividing by 5. That's true, you're dividing by 5. For a scale factor, we have to think about what you're multiplying by. So dividing by 5, if you remember with division, keep, change, reciprocal, dividing by 5 is the same as multiplying by 1/5. Good. So 1/5 in that case would be your scale factor. Does that make sense? Okay, so a way we can get the scale factor, because sometimes the numbers might not be quite as nice, a way we can get our scale factor is by taking a new length divided by the original length. New length divided by the original length gives us our scale factor. If it doesn't come out nice, you can just leave it as a fraction. Like if my new number was 2 and my original number was 3, I'm just going to leave that as 2/3, because 2/3 is a repeating decimal if I divide it out. Okay? If it was like 3 and 6, 3 over 6, you know, if you divide that, you get a half or 0.5. Either reduce the fraction or, in that case, a decimal would be okay as well, I guess. But again, it's the new divided by the original when you do that. Okay, so if you look at example 1, so a landscape architect designs 2 open green spaces. She designs the larger space so the length of each side is 3 times the length of its corresponding side in the smaller green space. Where should the architect draw the larger green space? Okay, so what we're doing here is to start out with, we have this rectangle, and it's a 1x2 rectangle. If we make those 3 times as big, they're going to go to a 3x6. 1 times 3 is 3, 2 times 3 is 6. The question is, where do we need to put that rectangle on our coordinate plane? And there's actually a way of doing this. We're not just randomly saying, oh, I'll scoot it over here so it's not in the way of my first rectangle. It actually is that we're using a scale factor of 3. Point A, right now, point A is at coordinates 1, 2. If it's at 1, 2, we're going to multiply the x and the y coordinates by 3, and that's going to take us to the point 3, 6. So if you'll notice, A prime is at the point 3, 6. That wasn't just a random thing of them just scooting it over to the side. They actually had a method behind how they did that. Okay, B right now is at 3, 2. So 3, 2, if we multiply those both by 3, that's going to take us to 9, 6. So 9, 6 you can see up here. Same thing with C and same thing with D. So this is 3, 1. It's going to go to 9, 3. And D was at 1, 1. It's going to go to 3, 3. Okay, so just use your scale factor, multiply the x and the y coordinates by that scale factor, and that'll tell you the new coordinates of where your points should go. So we look at the triad. We have a f prime, g prime, h prime, I prime, and a f, g, h, I. There was a dilation with the center at the origin, and they're asking what is the scale factor. So the scale factor, a couple ways we can do this. We can look at the coordinates, or we can look at the side lengths, or if you want to double check yourself, do both of them. If both of them work out the same, you're guaranteed almost that you have the correct answer. Okay, this is a change in the book then. They want the ratio of the side length of f prime, g prime, h prime, I prime to the side length of f, g, h, I. So on the prime one, we've got a square. Each side has a length of what? 5, okay? On the non-prime, our original figure, each one has a side length of 1, okay? So the ratio of the prime one to the non-prime one means we put the prime one on top. That would be a ratio of 5 over 1. 5 over 1, that divides out nicely, and that would be the same as 5. So our scale factor then is 5. Okay? Now, like I said, if you wanted to assure yourself that you have the right answer here, make sure you counted your squares correctly. F was at 1, 1, and now it's at 5, 5. Well, how do we get from 1, 1 to 5, 5 is we multiply by 5. So our scale factor is 5 in going from the blue to the red. Does that make sense? If we were going from the red to the blue, then it'd be the other way around. It would be 1/5. Okay? And this is like we talked about earlier. Remember our ratio, it's the new over the original, right? So this is our new square. This is our original square. That's why we put it as the 5 over 1. So we got to make sure you put it in the right order when you do your scale. Otherwise, you might be enlarging or shrinking. You might be doing the opposite of what you actually intend to do. And when we get our scale factor, if our scale factor is more than 1, that means that we're enlarging the figure. If the scale factor is less than 1, that means we're reducing or shrinking the figure. Okay, so think about that when you get your answer. You know, get your answer and then think about, did it enlarge or did it shrink from what it was originally? So example 2 talks about coordinates now. What are the coordinates of the image ABCD after a dilation with center 0, 0 and a scale factor of 2? The center 0, 0 or the center of the origin, that's what we're going to be doing on all these problems. Okay, scale factor is 2, so that means we're going to be enlarging this. It's going to be basically 2 times bigger than what it was before. So A To start with, A was at 2, -2. Scale factor is 2. We're just going to multiply both of those by 2. So 2 times 2 is 4. -2 times 2 is -4. That's how we would get this 4, -4 that they have here. Okay, same thing with B was at 2, 1. Multiply both of those by 2 would be 4, 2. Okay, and you can see the rest of them, they've got worked in your book there. Okay, again, just doubling each of the X and Y coordinates in order to come up with that graph. Okay, and this is what I was just talking about a minute ago. When our scale factor is greater than 1, that's an enlargement because the image is larger than the original figure. So we look at example 3. What are the coordinates of image PQRS after dilation with center 0, 0 and a scale factor of 1/2? Scale factor of 1/2 means we're multiplying everything by half, which is the same as dividing by 2 if you think about it. So 6, 10, we take half of each of those is 3, 5. 10, 10, half of those is 5, 5. 10, 6, half of those is 5, 3, and 6, 6, half of those is 3, 3. And then you can see when you graph this, this is half as big as what it was before. Okay, this had a side length of 4, now it has a side length of 2. That's half as big for our side lengths. So that's how we know that we did that correctly. And this one, we have a scale factor between 0 and 1. That's called a reduction because the image is smaller than the original figure. Okay, we've reduced it, or sometimes we might think of it as shrinking something. They're calling it reducing it. So if we look at the triad, we have a dilation that maps points L to its image L prime at 2, 4. Complete the dilation of the figure and label the image. What is the scale factor? What's the length of side MN? Okay, so they're asking us to do several things here. One thing is the image L prime is at 2, 4. So I'm going to go ahead and graph that point first of all. 2, 4 is L prime. And probably not a bad idea if we just label this as well here so we can see what's going on. This is 3, 6. This is, again, 2, 4. Okay? So to figure out our scale factor, it's the new divided by the original, or new divided by the old if you want to look at it that way. So you can look at any part of this that you want to. You can look at the X coordinates or you can look at the Y coordinates. We don't have a figure drawn yet, so we can't divide the side lengths out, okay? But either X coordinates or Y coordinates, you should get the same thing. So our new X coordinate is 2. Our original X coordinate, or our old X coordinate, is 3. So 2/3 should be our scale factor. And you can check that with the Y's. With the Y's, the new was 4, the original was 6. 4, 6, that reduces to 2/3. Okay, so that confirms this. Scale factor is 2/3. So now let's look at the coordinates on our other points. Coordinates of point M are 3, 3. Again, when you're doing that, make sure you do alphabetical order, X and then Y. So over 3 and up 3. So 3, 3 are our coordinates now. If we're doing a scale factor of 2/3, what we're going to do is we're going to multiply each of those numbers by 2/3. So we put the 3 over 1 and then we are ready to multiply. So multiplying would give us 6/3. If you reduce that down You could say, well, let's divide both of them by 3. That'd be 2 over 1. That's the same as 2. So our x-coordinate was 3. Now it's going to be 2. Our y-coordinate was the same. If you want to work it out again, just to make sure you did it right, that's fine. Otherwise, if you're confident with that, we can just go with it. So our new point for the m would be, instead of 3, 3, it's going to be 2, 2. So I'm going to use a different color here so we can maybe keep track of this. M prime is at 2, 2. And then now we just need to find what n prime is. So n, first of all, let's find the coordinates for n. So coordinates for point n are 6, 3. And again, our scale factor is 2/3. So we're going to take the 6. First of all, 6 times 2/3. So multiplying those would give us 12/3. Divide that out would be 4. So that means our new point here is going to be 4 something. The 3 we already did. 3 times 2/3 is 2. So we're going to be at 4, 2. And this would be our new triangle. Once we've got that triangle, kind of look at it and see, does it look similar to the other one? You can also look at the side lengths. The diagonals don't work, but the straight side lengths, these were each 3 units long, and then the new ones now are 2 units long. So that confirms our 2/3 ratio, 2/3 scale factor that we talked about. And then the other question they asked was, what is the length of side m prime, n prime? And we just actually mentioned that. Length of side m prime, n prime would be 2 units.